Earlier, I explained that in classical mechanics, there are three different kind of formulation of mechanics like Newtonian mechanics, Lagrangian mechanics, and Hamiltonian mechanics, which are different to each other, though they are equivalent to each other. These three explain same mechanics. It means we are using this different kind of mechanics for different purpose. Similar to classical mechanics, in quantum mechanics, there are many different mathematical formulations which we use according to our ease and according to our purpose. What phenomena we are studying? First and foremost, quantum mechanics formulation is wave mechanics, in which we study the evolution of quantum system with time. Earlier I explained Schrodinger equation, what is response probability interpretation. These whole concepts fall in this formulation. Second interpretation is matrix mechanics, which was given by Heisenberg and other physicists at that time, which is also equivalent to wave mechanics. In this interpretation, or sorry, in this formulation, physicists use matrix to explain and to represent various physical observables of quantum mechanics. In this video, I am just stating all this formulation. In another longest video, I will compare all this formulation so that viewers can understand their applications also. Third mechanics is operator mechanics, which was given by Paul Dirac. In this interpretation, Paul Dirac used Ray-cat operator to represent equations of quantum mechanics, and that is what is known as operator mechanics. Here we are using operators. Another important formulation is path integral formulation, which was given by Richard Feynman to understand quantum field theory, which is the unification of special relativity and quantum mechanics. We know that to understand which path electron will go from slit to spin, Feynman used this in formulation, and that is why it is also known as sum over history, in which we are summing all path of electron, and ultimately we will have integration of this whole path so that we can understand quantum field theory. Another interpretation is space formulation, which is very less familiar. In this interpretation, quantum states are understood as quasi-probable distribution in classical phase space. That I will not explain here. I will cover in the other longest video. Another interpretation is density matrix formulation, which was firstly developed by von Neumann to understand statistical mechanics, entropy, and information theory, in which they used mixed and pure quantum state. That I will explain in another video. Another important formulation is second quantization, which is widely used in various quantum field theory and quantum theory of gravity. Dirac used this interpretation in various quantum theory of gravity theories. Another interpretation is variational formulation, in which convergence of equation of quantum mechanics into optimization problem are considered. This formulation is widely used in quantum chemistry to understand many body problems. And last interpretation is geometric formulation, which use symplectic geometry and different kind of geometry to understand quantization problem. This formulation is widely used in quantum theory of gravity, like causal dynamic triangular, low quantum gravity, causal sets, etc. So here I am just explaining various formulations of quantum mechanics, and in the another video we will see different points of comparison between all these formulations.